You know, what if the blueprint for our future wasn't hidden away in some high-tech lab, but was actually all around us, in a forest or a field or even our own backyard? Today, we're diving into a truly revolutionary idea that's changing how we build, well, everything. It's not about inventing new rules from scratch. It's about finally learning to read the oldest instruction manual on the planet, nature itself. And right away, a question like this just reframes everything, doesn't it? We think of a spider's web as this delicate, fragile thing, but pound for pound, it is one of the strongest materials on Earth. And that one simple, incredible fact is the key to a radical new way of thinking about engineering, one that stops seeing nature as an obstacle to be conquered and starts seeing it as the ultimate mentor.
So let's take that idea of a mentor and just scale it up. What if this mentor hasn't just been around for a while, but has been running R&D, perfecting its designs for 3.8 times billion years? I mean, think about it. Life on Earth has already solved the very problems we're wrestling with right now. Things like energy, materials, incredible efficiency. We just never really knew how to ask for the answers. Until now.
Okay, so this whole approach has a name. It's called biomimicry, and it is so much more than just making an airplane look like a bird. That's just scratching the surface. This is a really deep, conscious effort to understand the principles behind nature's designs. We're talking the chemistry, the physics, the systems, and applying that absolute genius to our own challenges. Really, what we're talking about is a fundamental shift in our entire mindset. For most of human history, we've been in a battle with nature, trying to tame it, to conquer it. This new paradigm is all about collaboration. It's the difference between blasting a tunnel through a mountain and learning how a leaf perfectly harnesses sunlight. It's about trading in brute force for brilliant efficiency. So, what does this actually look like in the real world? This is where it gets really cool. Let's take a look at 3 of nature's master engineers who are already giving us some incredible lessons. And our first teacher is one we probably sweep out of the corner of the room without a second thought, the humble spider. But its craft isn't just about catching flies. It's a masterclass in material science. Remember that spider silk is 5 times stronger than steel? Well, it achieves that incredible strength without the massive weight and the huge energy cost of producing steel. So, by mimicking its molecular structure, we can now create new biopolymers. Imagine suspension bridges that are lighter, more flexible, and potentially even stronger than anything we have today. Okay, next up we have an architect whose work is, quite literally, groundbreaking, the termite. These tiny insects build these massive, incredibly complex structures that have one feature our own skyscrapers desperately need. This is nature's efficiency at its absolute best. A termite mound can maintain a perfectly stable internal temperature, even when it's blistering hot outside. And it does this with a brilliant system of vents and tunnels. It's perfect passive cooling. Architects are now designing living buildings based on this exact same principle, creating structures that literally breathe, which could dramatically cut our reliance on those power-hungry HVAC systems. And for our final teacher, we're going underground, and honestly, a little bit into the future. We're talking about mycelium, the root network of fungi. This is where engineering stops looking like construction and starts looking a lot more like cultivation. I mean, this fundamentally changes the definition of building. Right now, we are using mycelium to literally grow bricks that are stronger than concrete, totally fire-resistant, and completely biodegradable. And the idea goes even further. Think about biology's ability to repair itself. Now imagine concrete that can heal its own cracks, just like your skin heals a wound. We're moving away from building static, dead objects and toward creating dynamic, living systems. So, you take the spider's strength, the termite's efficiency, and the fungus's living design, and when you start putting these lessons together, a whole new vision for our future starts to emerge. One where we build a world that functions just like a natural ecosystem. And the ambition of this field just keeps growing. It started out pretty simply, by just mimicking form, like shaping the front of a train like a bird's beak to make it quieter. But now, we're mimicking process, like photosynthesis, or the way termites cool their mounds. And the final goal, the real game changer, is to mimic entire ecosystems, to create cities that don't just consume resources, but actually clean the air, filter water, and integrate seamlessly with the world around them. And you have to understand, this isn't some far-off sci-fi dream. This is the tangible vision for as early as 2026. We're talking about bridges that are responsive, that flex like a muscle,
materials that are self-sustaining, using advanced 4D printing to literally grow structures right on site, buildings that are active, breathing participants in their own climate. This is a city that finally works with the planet, not against it. You know, human engineering really began with something as simple as stacking stones on top of each other. The next great leap forward is to build with the wisdom of a spider's web, to create complex, resilient, and beautiful systems, but this time on a planetary scale.
So, it turns out the greatest innovator, the most experienced engineer, the most creative artist, it's been right here the whole time. The only question left is, after centuries of trying to shout over it, are we finally ready to be quiet and just listen?